So we created the aggregate. Now we'll look into the network section of the Ontap, and in this document we can see like what are the component which are used to create the to perform the networking of the on Netapp product. And first we have ports, we bundle it together, and we can configure those bundle or the ports under the broadcast domain, and then those broadcast domain is utilized to create the lifts and on the top of that lifts will delegate DNS name can be on box or off box. It totally depend upon the environment how you want it. So then the DNS has been created, and that DNS has been accessed by the client. So IP spacing is basically like it's a environment like a company has gone through the merger or something. There's some configurations like that. You have two private network with the same IP segment, but you both of them, both of the clients, they want to access the storage from the Netapp. So this IP spacing will create a separate two islands, and they could able to access the data from the same Netapp box. So you will very rarely see the IP configured in the organization like more than one IP space unless the organization has gone through the merger or something. Okay, so let's look into the lab so that we can wire up all this connection and how does it flow. So this is the Ontap 9.9, and the big problem which I have faced that there is an option to create the IP space, but like we can create the IP space using this, but there's no option to create the broadcast domain. So to demonstrate right now, what I'm going to do is utilize the CLI, and I'll demonstrate how to perform the network configuration part. And one more thing, like since I will not able to create the aggregate right now because of the basic simple principle, like if we perform the nick teaming on the host, then there has to be a port channeling on the switch as well. But if I do create the aggregate over here, I don't have access to the switch to perform aggregate over there. So the communication will not work, and we will not able to test out. So let's go ahead and perform, and then you will understand how all these things are connected and wired up. Okay, so by default there's a one IP space for cluster and one for default, and I'm just going to create the one IP space right now. Let's say some ABC company. For the ABC company I need to create. So this is a IP space which has been created. Now this we can do from the UI as well. Like if I want to create, I can simply click over here and create the IP space. But the problem is broadcast domain. Then because there's no option like I could able to create the broadcast domain. That's why I need to go by a CLI to create that broadcast domain. So let's see the our present configuration. Okay, see 10. Okay, see 101 101D. So already D and F is already utilized. A and B is being utilized to create the cluster. It's a back cluster network. So what we are left out with, net. Okay, so we can't use A and B, those are in cluster. We are left out with C, D, E, F, G, H and X. From here D and F is already utilized, so okay, we'll take out G. G is not utilized by the 0 2. Yeah, we'll take out the G for our test environment for ABC and company, which ipspace with the ABC is mainly created for the ABC company. So I need to take out those ports from the broadcast domain. I need to remove those ports. Space, it is in default right now. Broadcast domain default. I need my port in this cluster. It is E0G. Okay. And let me remove from 0 to G. Okay, so I have removed those from the 0 to I'm not doing the link aggregation because I don't have much access to make a port channel, so I'll just straight away utilize this port and I'll create in my new I'll add that in a new broadcast domain which I'm going to create for the ABC. So this is a broadcast, and now I will add those ports into that particular domain. Network port, broadcast domain, add ports, ipspace, ABC, broadcast domain, ABC, ports. I will use 0 2 for 1 and 0 1 E0G. Now if I will verify, I'll see my port has been delegated for the ABC network. Okay, since I have received, so here now this is, I could able to see like my broadcast domain ABC has been created. Port E0G from both the nodes has been added to this broadcast domain. So I'll proceed with the creation of subnet for ABC company. subnet I will create, and this subnet will be created in the IP space ABC and broadcast domain ABC as subnet 192.168.0/255. We can't give the subnet mask like /24. You have to write it like this complete, and then gateway 192.168.0.1 and IP range. I'm going to specify, give 10 IPs ranging from from the 70 to 192, 168, 0 dot 80, and subnet name is ABC. So I got my subnet created. This is I have 12 IPs reserved from range from 70 to 81. So since I have created this, I need to create a leaf, and leaf will be is a logical entity, and which gets assigned to the vserver. Vserver has to be in the same IP space. So at present I don't have, so I'm just going to create one vserver in the same IP space. Let's take an example. There's a XYZ is my vserver which need to be created for my this company ABC. I'll use HTTP4, and I need to create this in the IP space ABC. So it will create the vserver in this. Since I got my vserver, this vserver should contain one NIC card, logical leaf. So I'm going to create the leaf from both the nodes, node 01 and node 02. C1 XYZ I'm going to use for NFS, and data protocol it will use NFS. Subnet range will be ABC, and home node will be, for cluster 1 it is going to be a cluster
01, and similarly for second node I'm creating 2 leaf, second leaf. So basically the request can be served from 1 leaf, but I'm creating 2 leaves for the to have the proper load balancing of the traffic, and that will be served with the help of uh, DNS. So now there's a two box, on box and off box. So if I want to go with the on box, I can use forwarding lookup zone, and I can create two. And other option is on the server. So just need to verify what IPs has been assigned to these interfaces. So they got 70 and 71. So out of 12 subnets, 2 has been utilized. So 70 and 71 has been utilized, and if more interfaces will be created in the ABC segment, it will keep on consuming from this particular subnet. Now this has been created, so I'm going to create the DNS on on this particular on box instead of creating off box. So network show network interface DNS. What? So right now there's no DNS on the box created. So we'll create one network interface, modify this interface and give modify vserver XYZ. And this is going to be abc netapp.com. Likewise for second interface also I'm giving same DNS, so that load can be shared. And see, it has been created. So I'm just going to create a one conditional forwarder over here, which is my abc dot netapp.com, and it is 192.168.0.70, and the other one was 192.168.0.71. So anything which is matching to this particular DNS name will get the response from these two IP. So this one has been created, so we will verify right now. The response is coming from 71. Now it is coming from 70. So this is how the load balancing is working within this particular with the help of DNS on box DNS load balancer. So I'm reachable, and this is how the network configuration is done. And just for the sake of understanding, once again I'm going to explain. We created the namespace from we create the namespace, and then we delegated certain ports to the that particular broadcast domain which belongs to this namespace. This is my IP space, and this broadcast domain contains all the interfaces where we didn't create the link aggregation. Otherwise, if we would have used the link aggregation, then it will uh, have that information, that end ports. So it contains all the ports on the once we delegated those port in this uh, domain logical configuration which we did here. We created the LV SVM, which is we also known as vfiler, because in server mode it used to be vfiler, and this SVM is created under the same umbrellas, under the same IP, this IP space. And once this has been done, we then we can create a number of logical lifts from the SVM. It is a logical entity which can be a number of that, and with IP is been delegated from the subnets. So what we did, these are the lifts from the SVM, and these are the lifts. This is logical. We can create as many as what we want. There must be some soft limit in documentation, but we can create multiples, and the IPs to this will be delegated from the subnet which we have created in the same IP space. So in this IP space we created one subnet, and which help to delegate the IPs to this leaf. Once the leaves attain the IP, client will the customers, they will talk to the IP of this particular, these clients will talk to this logical leaf, and the connection goes to SVM, and SVM will have the tight integrations uh, with the volume, so which we'll explore further. So as of now, this is how the physical connection is happening. The client is connecting from the clients are connecting from outside, and from the intranet to the Netapp box. Okay, and yeah, so one more thing is we created the DNS name. We use the inbox. It can be out of box, so like we can create a name and number, like number of lives, and corresponding to that number of lives we can create the DNS name. But we use the on box, and we create the DNS zone here. So we created DNS zones here, zone which is like on box DNS load balancer. So this is what we did in the network section. So this is a most time consuming, tedious and plan uh, activity which requires more planning. So that's why this video is a bit longer. Okay, thank you.